calculus, we've done now the sketching, now we're actually into finding equations. Because is this really finding the equation? If I say there is an expression, it is a cubic thing, and I'm asking you to find A. Because the only variable that I see is A. So it's not in the form ax to the 3 plus bx squared plus dx, it's cx plus d. And that's okay. And if I find that, so it's actually finding the equation, but you don't have to go with the formula of the 3x intercepts, because something else has been given here. So it's something new, something to look out for, and there's huge amount of things that they can do. We read the question and they say, go find it, just go find A, but they're giving me if it has a maximum of, I don't know what, but it's add 3. So now maximum. What do I know about maximum in calculus? It's a turning point. Derivative. If all else fails and you're inside of calculus, at least derive. You with me?
Yes.
It's worth them all. So you have to do the derivative. And why would you do the derivative? Because if it's a maximum, the turning point is going to be where the maximum is equal to 0. The derivative is equal to 0. So if I go to that sum, and I'm saying dy dx because they never gave me fx. I always love it when they say fx, so it's f dash. Okay, so do the derivative for me, please. 3a. How can I do that? A is a number, right? I don't know what it is, I'm going to find it, but I'm going to find it by saying derivative is 3 times the a and take away 1 from the exponents. So I don't know what the a is, but that's the coefficient now. And then plus 54 must be equal to 0 because it's a turning point, a local maximum or a local minimum. And to find the value of a, I need the x. Of what? The turning point. That's why they gave me that x was equal to 3. So you substitute your x with 3. So 3 times a times 3 squared plus 54 is going to be equal to 0. So we work out our sum. 9 times 3 is 27a. Am I right? Yes. So that a would be equal to negative 54 over 27, giving me a's value of negative 2. Question was just find a. I found a. I'm done. There's lots of other stuff to do. Now that I know it's negative, I know that the graph is going to look negative. I will be able to find x-intercepts. I will be able to find turning points. Y-intercept is 0. None of that was asked. So the question would have been worth something like the derivative equal to 0. Because that's what it's all about. Knowing that it's a maximum, it's a turning point, the derivative is 0. And substituting the 3 and working out your answer. That's it. Okay. Question number 12 has 2 variables. They're giving me an expression of a cubic graph, but it's a little backwards. And nothing is preventing you from writing it with the x to the 3 at the front, then the x squared, then the x, and then the number. No problem. They gave it to you like that. And then they said, obviously I'm looking for a and b, I think. They said, has a minimum point at. So what is that? The turning point. The minimum turning point, the local minimum. So what do I know about minimums or maximums? You take the derivative and put it equal to 0. And remember that the derivative is actually finding the gradient. So the gradient is just dependent on the x value, not the y value. So that is going to make the turning point be a turning point where the gradient is equal to 0. Not the negative 13. The y value just works together with the x because every x has a y. But the gradient is dependent on the x value. The x determines the gradient. So if I know that it's a minimum point, in essence, I know that it's got a gradient of 0. Now there's more than one way of doing it, because the other class said the moment that I have a point, I can substitute the point, and you're quite right. You're going to do it at some stage. part of the sum, one of it is that you're going to take that point and put it into the original sum. But if I put x and y in here, I'm still going to sit with b and a. So that makes me think simultaneous equation. Fantastic. So you can start with that, or to me, I read minimum point first. So I know that the turning point is going to be where the gradient is equal to 0, and that'll happen where x is negative 2. I'm starting with the turning point. So I'll still have to go and use the point as itself. So whenever you've got a turning point, you can always use it in two ways. Use it with the derivative equal to 0, and use it as the point that you're just substituting in. So you'll always get two formulas for that. The moment that you've got a turning point, you've actually got two sets of information. Just as a point substituted in, and the derivative equal to 0 because it's a turning point. Always, guys, this is a very important point that I'm making. The moment you have a turning point, you can use it on two ways. As a point substituted, and in the gradient, which is the derivative, you put it equal to 0. Now let's do derivative again, just like this strange one. Derivative of b is 0 because b is a constant number. I don't know what it is yet. I'm finding it now. But I know that its derivative of b is 0. Derivative there would be 8. Oh, sorry, I missed my A. Equal to, remember that this is gradient. And the gradient changes from point to point, wherever my graph is, and I'm not even going to do a graph now. But from point to point, the gradient will change. And the gradient depends on whichever x value I'm at. Now, at the turning point, I am at x equal to negative 2. But I've got to fill in here. So I've got 8 minus 8 times negative 2 minus 3a times negative 2 squared. Obviously, I'm trying to solve for a. So just be careful and don't do this too quickly. So we've got, if I'm correct, so we've got 24 equals 12a, and a is equal to, fantastic. If I did it without cooking it right, and they say show that a is 2, fantastic. You cannot start the sum and say, okay, they said a is 2, so let's go for it, put it in there. So you're missing all these marks. So now that I know that a is 2, I can say that the original function is y equal to b plus 8x minus 4x squared minus 2x to the power 3. But you can't start there. If they say prove it is, it will be. They won't say show it is and it isn't. It will be, but you can't start here. So now if I know what a is, I just need to find b. So it seemed like we were going to work with simultaneous equations, but since the one already just solved for a, I just have for b to solve now. If you had done it the other way around, it was a little bit longer, 1 or 2 steps, but it's fine. So what can I do now to find for b? Okay, remember, you're going to use the turning point twice. Once for derivative equal to 0, and one just as a point on this graph, where the negative 13 also has to take its place. And x value is negative 2, and negative 2. And when you solve this answer, I'm not sure I can remember correctly, but I think the answer was 3. Just check up on me, please. So timing it out, adding it all together, taking it to the other side. Just check up on me if the answer is 3. And if I'm done, the sum is finished. Done. So there will be marks for derivative equal to 0, solving for a. Not for the answer because they gave it to you, but working correctly here would be the answer that I can see you doing it yourself. You're not just taking their answer. Going back and substituting the point and getting to the b value because they didn't give you. Is the answer 3? Just check.
Yes.
Okay, thank you. So now I could go back and say, well, so that's 3 and that's minus 2x to the power 3. Can I sketch that thing? Find turning points. One of them better be that one. Find x-intercepts by using Bachman, synthetic division, etc., but they don't put them all in one sum. So you never know which of the stuff is going to be in the sketch of the graph and where they use the information on another way. Okay. This is a little bit difficult to grasp. Once you have it, you're always going to have it. I need to teach you something else now. When they give you the graph of the derivative and they ask you to find me the original graph, first of all tell me if the derivative is a quadratic, right? Parabola is quadratic. Then what was f? Cubic. Fantastic. So either, I'm quite sure, either it's going to look like that or it's going to look like that. Remember, we do have those ones that just have an inflection point that never turn. Well, that can also happen, but this won't be the graphs over here. They do something else. So I need to teach you something. So do not write anything, just focus for a few minutes. I need to teach you that what is given on here now, please tell me what is a derivative? Originally I said to you, please remember if I said, did you get the derivative, you're getting the gradient. Fantastic. So, if this is the x-axis, this is not the y-axis. This is the gradient axis. Okay? Focus, children, focus. So, it's representing for every x, there's a certain gradient. Because f accent, derivative, is showing you the gradient. So, I'm saying that, looking at this graph, the gradient, and if I do it this way, and I'm going to teach you to do it now, always to say that is where your gradient is. So remember, graph m is positive. This will be where your m is. But man, something's not lacquer. Because your brain doesn't want to compute that so lacquer. You thinking parabolas, positive gradient, negative gradient. Stop it. Don't think that. That's for parabolas. What are we working with? Gradient. Gradient. This is representing a gradient. So treat it like this is your m-axis, not your y-axis. So positive and negative gradient don't apply here. I'm showing you the gradient, positive above, negative below. So let's read it together. In South Africa, we read from the left. So first of all, the gradient was negative. Are you feeling uneasy? Gradient negative.
Yes.
You're feeling, doesn't feel right. Gradient is negative. Then the gradient is?
Positive.
Sure. Positive. Feels uneasy. This gradient is positive. The gradient is positive. And then the gradient is back to negative. That's the first one I feel comfortable with. Because it's not positive, negative. No. When I'm looking at the derivative which shows me the gradient, I've got to read it as, first there was a negative gradient, and then there was a positive gradient, and then there was a negative gradient, and that's the shortcut of knowing. Which one of the two is it?
That one, the up one. That one.
Negative, positive, negative. Sketch graph only. So if I have to go do this on a graph, I would say, okay, all I know, where's the turning point though? Where does this direction change take place from a negative gradient to a positive gradient to a negative gradient again? It changes at the turning points. Where are the turning points? Where the gradient is zero. Where's the gradient 0? Gradient is 0 at x equal to -1. Gradient is 0 at x equal to 6. So you're starting to learn to read this differently. So the gradient is 0 where x is -1. The gradient is 0 where x is 6. So on a graph, the only thing for a sketch graph, that I can use with the information given to me, it's not going to be accurate. All they're jolly giving me is the x value, not even the y. Is at -1 and at 6. All I know is that between those two turning points, the gradient's got to be. So somewhere, somehow, there must be something taking place like this. So I'm saying, estimation. There will be a turning point somewhere at -1. Where? I don't know. Anywhere you like. At -1. And anywhere you like at 6. But it's very important that the 6 one is a little bit higher and the -1 is a little bit lower so that the gradient between can be 0. Okay, are we back to positive gradient here? And negative gradient there. And negative gradient there. Yes. Now I'm back to normal graph, which name was F. Here I can now speak about negative, positive, negative again. But this, the derivative graph, represents the gradient. So, the gradient being negative, then positive, then negative, will lead me to know that it's got to be that shape. Somewhere, because this will be a mark of 3. If I ask you the sum. According to this information, please give me a sketch graph, just with the information handed to you. So where can this be? Anywhere you like. It could have been there and there, or there and there. Doesn't matter, but it has to be positive gradient. So this one's going to be a bit lower, and that one's going to be a bit higher. Does that make sense? Man, what is that coordinate? I don't know. And that one? I don't know. Man, you always tell me to get the x-intercepts and the y-intercept. No, Get me a sketch graph only with the information given to you. So all that they're testing is if you know that this represents the gradient. Are you with me here? Another question that they could have asked me here, because I'm done with the sum. What does that represent? Y-intercept?
No,
The gradient is 7. Where? X is 0. The gradient is 7, where x is 0. Apply it here. So where x is 0, that gradient will be. Doesn't mean anything to my sketch, but it applies. Positive gradient. Are you with me? If there was anything over here, would it be negative? Are you with me? Okay. So the gradient is 7. The gradient is 7 in the point where x is 0. It's way backwards. Agreed. Luckily, there's only two things that can happen. Either the parabola can be negative like it just was in the previous example, or a positive parabola, but please remember, the moment that you see that, this does not represent x. Why? This is your gradient. So first thing that you do is you write here, positive gradient. Okay, so reading from the left. First the gradient is positive. Then the gradient is negative. Don't think negative, positive. This gradient is negative between 2 and 8. And after 8 it's positive again. Okay, so what must the graph look like? First positive, then negative, then positive. So that's what your graph's going to look like. That's a little bit pushing your luck for marks, because I need some more. What do I need? The turning points. That's where the gradient is 0. Gradient is 0. So between 2 and 8. So if I had to go plot this on a graph, I'd say something like, I don't know what, that would be at the point where x is 2, and I don't know what, because I can't work it out, I don't have an equation. And then the other one would be where x is 8, but it has to be negative gradient between 2 and 8. Negative gradient. It's confusing to you because it's negative. You're feeling negative, positive, and it's not. This represents positive gradient for x less than 2, positive gradient. Positive gradient for x larger than 8. So larger than 8, positive gradient. But between 2 and 8, the gradient is negative. So negative gradient. Here, you're allowed to think positive, negative, positive. Here, you're not allowed to think negative, positive, because it's representing the gradient. Okay. What else? How many marks for this? The shape and placing the x-intercept at the right place. Right place, no. Anywhere, as long as the turning point's a little bit higher and this one's a little bit lower, and that can happen. So I'm going to give you one with the straight line and with its turning point as well. The straight line. Let me help you quickly. If it looks like this, and I tell you that this is the derivative, what was if? If the derivative is a parabola, the original one was a cubic. If the derivative is a straight line, the original one was a parabola, quadratic. So the quadratic one, but please forget all about that. Just know it's a parabola. First thing you do is know that this is your graph. So this is where your gradient is positive, and this is where your gradient is negative. So what happens to this graph? It's first got a positive gradient, then a don't think negative. First positive, then negative. Show me with your hands. First positive, then negative for a parabola. Excellent. So that's what you have into your graph. Where? Oh, I never gave you anything. Let's make it a 4. So at 4, you've got a turning point. So wherever 4 is, somewhere it's turning. Where do you want it to turn? Somewhere there. And it must turn. So it should have a positive and then a negative gradient. Anywhere. First positive, then negative. First positive, then negative. And it turns at x equal to 4, the gradient is 0. First positive, then negative, according to that, and that would be your, sorry, I said F, not G. F. Right, I'm giving you homework.